In this video, we will see the Mason's gain formula to compute the transfer function. So this is the formula to compute transfer function. Transfer function is equal to summation of pk del k divided by del k varies from 1 to n. N represents the total number of forward paths. N represents the total number of forward paths. Suppose you have a 2 forward path, then n is equal to 2. And pk represent gain of the kth forward path. If there are 2 forward paths, then you will have p1, p2. So p1 will be the gain of the first forward path and p2 will be the gain of the second forward path. So before we move on to del k, we should know what is a del. Del is nothing but it is given by this formula. See, first we have to identify from the given signal flow graph how many individual loops are there. Okay. After finding the individual loops, find the loop gain of every individual loop. Sum all the individual loops gain and put it here. That will be this term. That is identifying all individual loops and finding the loop gains of individual loops, sum it and give it here. That will be the first term. The next term is in the signal flow graph, you have to look into how many pairs of non-touching loops are existing. For example, if there is only one pair, that is there is only two non-touching loops that are not touching each other. So then calculate the gain of this pair. That is you have to product the gain of the first loop and the gain of the second loop and make it into a single term. So that has to be supplied here. Okay. If you are going to find two sets like that, then the gain product of the first set and the gain product of the second set has to be summed and given here. Suppose you find three sets which are not touching each other, then you will get three terms, okay, and that has to be summed and it has to be given in this place. Okay, that is what is the meaning of combination of two non-touching loops. When you do problem, you will understand better. Okay, so this is sum of gain products of all combination of three non-touching loops. That is, you have to look in the signal flow graph. Is there three loops which does not touch each other? So if you find a set, okay, there are three loops which does not touch each other. You are finding only a single set. Then you have to multiply the gains of these three loops and supply it here. Okay, if you are finding two sets like that, okay, one set of three loops not touching each other, another set of individual loops which are not touching each other, then you get two sets. When you get two sets, then you will have a two terms. One will be the product of first set and another will be the gain product of second set. Those two has to be summed and supplied here. Okay, so when you do problem, you will feel comfortable. Okay, as of now you just know this formula. So that is that del and it has to be supplied in the denominator. And del k is very simple. It is the same as del, but it has to be applied to which part that matters. You have to apply del to that part of the graph which does not touch the kth forward path. I repeated, the del formula has to be applied to a particular reduced graph which does not touch the kth forward path. Okay, if it is if we are going to calculate del 1, then you have to draw separately a signal flow graph which does not touch the kth forward path, first forward path, and then apply the del formula to it. That will be the del k. Okay, so that is del k. We will do a few problems, then you will be comfortable with this particular Mason's gain formula. Okay, so here is a signal flow graph. Here is a signal flow graph. Now let us find the transfer function. The first point is you have to find how many number of forward paths are there. Let us identify how many number of forward paths are there. It should start from the input and it should reach the output. Which path reaches that way? This is one path. Okay, so the gain of this path P1 will be 1 into G1 into G3 into G4 into 1. Okay, this is the path 1, P1. Is there any other path? So please see, is there any other path? Yeah, there is another path from this point. You go like this and go out. Okay, there is another forward path. So totally two number of forward paths. So capital N is equal to 2. So you will have a two forward path gains. One is this fellow's gain and another one is 1 into G5 into 1. So you see that there are two forward paths P1 and P2. So the next point is you have to find how many individual loops are there in this. Okay, you see individual loop here and another loop is here and there is another loop here. Okay, so there are three individual loops. There are three individual loops. This will not come under loop because this is not a feedback path. Okay, there are three individual loops. What are the gain of these loops? This is a self loop, so you have only minus h1. This loop's gain is minus into g3 into h2, and this loop's gain will be minus g4 into h3. So there are three individual loops. So your first term is ready for del. Okay, and second term is in this signal flow graph you have to identify, is there any two loops which are not touching each other. Okay, is there any two loops which are not touching each other? If you look at there are only three loops, so it's our work is simple. So there are two loops here which does not touch each other. These two fellows touch each other at this point D, whereas this loop and this loop does not touch each other. So this is one pair. This is one pair. Another pair will be this loop and this loop does not touch each other. So how many pairs of non-touching loops are there? There are two pairs of non-touching loops. Okay, so the first pair's gain, this fellow multiplied by this fellow, will be your first pair's gain, h1 into h2 into g3. Another pair's gain will be h1 into h3 into g4. That is, the first pair is h1 into h2 into g3. The second pair is h1 into h3 into g4. Of course, minus sign has to be there. Minus minus gets multiplied, so it becomes positive. So there are only two sets like that. Okay. The next thing that we should see is there three loops which does not touch each other? Is there a set like that? There is no set like that, because here at least these two fellows touch each other. There is suppose if this loop was here, then you will have a set, one loop, second loop and third loop, that becomes a set. But here three non-touching loops are not there. A set of three non-touching loops is not there. Okay, so the next term will, that is the third term, will go off. So you have only individual loops and two set of non-touching loops. Okay, two sets of two non-touching loops. So your del is ready here, that is 1 minus sum of all these fellows. Okay, that plus sum of these two terms, minus, actually if you have a set of three non-touching loops, that fellow's gain will come, but here there is no set like that. Okay, so the last term is not there. So del is equal to 1 minus sum of these fellows plus sum of these two gains. So del is ready for you. Now we should move on to del 1 and del 2. So there, in this formula you can see that since k is equal to 2, you got p1 del 1 p2 del 2 divided by del. Del is ready for you now. P1 is the path gain of first forward path and P2 is the path gain of second forward path. That also was ready. And del 1 is, you should apply del to that part of the graph which does not touch the first forward path. Okay, is there any part of the graph which is not touching the first forward path? Are you able to see that? No, all the graphs are all parts are touching this first forward path's nodes. Am I right? This path is touching here, this path is touches here, this path also touches here, and this is also a path. Okay, so there is no part of the graph which does not touch the first forward path. So del becomes obviously only it is left out with 1. So minus something, those things will not be there. and del 2 will be del applied to that part of the graph which does not touch the second forward path. Let us first find out which part of the graph does not touch the second forward path. So this fellow touches the second forward path. This fellow also touches. This individual loop does not touch the second forward path. Do you see that? This is a second forward path. So this individual loop and this loop does not touch the second forward path. So from this point to this D point, it does not touch the second forward path. So you have to extract this signal flow graph separately and apply del to it. So when you apply del to it, del is 1 minus sum of individual loop gains. So how many individual loops are there here now? This is one individual loop and this is another individual loop. So it is so you will have two individual loops. The gains of the individual loops will be, one will be minus h1 and another one will be g3 into minus h2. Okay, so that together forms the one path, and the next term will be identifying is there any pair of loops that does not touch each other. Yes, this is a pair which does not touch each other, so you have to product the gains of this fellow and this fellow. So you will get it as g3 into h1 into h2, okay, plus g3 into h1 into h2. These two are the first term, that is sum of individual loop gains. Okay, 1 minus sum of individual loop gains, and this minus will come out as a common and it becomes plus here. So del 2 is nothing but del applied to that part of the graph which does not touch the second forward path. Okay. So the first thing is you have to draw a separate signal flow graph. So I have to extract this graph separately. Okay. This B, C, D path alone, and then apply del to it. That's it. Okay. Applying del to it is, you know the formula for del, so you apply that. So 1 minus sum of individual loop gains. So there are two individual loop gains. So these two terms are the sum of individual loop gains, and then you have to identify how many number of how many sets of two non-touching loops are there. This is one pair of two non-touching loop. So gain product of that will be g3 into h1 into h2. So we have substituted here. There is no three loops, so we are cut shorting with two non-touching loops. So we got del 2, we got del 1. So substitute everything in this formula and you get the transfer function. Okay, so you got the transfer function here. Okay, it's just substitution. After getting p1, p2, del 1, del 2 and del, you just substitute it here, you will get the transfer function. So you please try once again at home this problem. Okay, we will see in the next video few more problems. Thank you.